So now, without further ado, it is my pleasure to introduce today's speaker, Manuel Garcia, Global Lead of Ipsos's Neuroscience Practice. Manuel, you have the floor.
Thank you, Ellen. Thank you, everyone, for joining. Welcome to my home in Brooklyn, New York. I am Manuel Garcia. I lead the practice of the discipline of applied neurosciences globally at Ipsos. As you can imagine, I'm a trained neuroscientist, and I'm also a professor at NYU and an author of the field of consumer neuroscience. And I'm very excited today to share with you some very interesting highlights of how neuroscience works at Ipsos. So this is the outline of this webinar today. So first, I will illustrate how neuroscience works at Ipsos quite briefly, because I think it's very interesting, because it's very different from what you might be used to in other research agencies. Then I'm very excited to share with you the dynamic decision-making model that we have created with our academic partners that actually illustrate the cognitive dynamics of decision-making in a comprehensive way, and going one step beyond the system 1, system 2 that many of you might be familiar with. But bear with me for a moment, because then we'll get you're probably most interested in some case studies applying neuroscience. This is all, and all these case studies are very according to the times that we're living. It's all things that can be done online and not face-to-face, and things that you could be applying to your research today. And then I will just briefly mention some of the fundamental new applications that we're working on at Ipsos in neuroscience to see what's next, right? So I really want to share how neuroscience works at Ipsos, because, as I said, it's very different from any other research agency. So I'm part of a group that's called the Global Science Organization that groups together a lot of scientific disciplines, including obviously neuroscience, but also behavioral science, data science, political science, in a team that's very nice. I'm very happy to work with colleagues from different disciplines, because we also get to learn a lot from each other. But then we work across all the different applications at Ipsos that you probably have used before, being creative evaluation, innovation development, market strategy, public affairs. So we work across all of that, infusing and supporting with our expertise in each one of our disciplines, and also cross-discipline. So it's all a very holistic approach, rather than there being a business in itself that focuses on applying neuroscience. The focus is to apply neurophysiological measurement, to apply neuroscience where it adds value across all the different offerings of Ipsos. And that takes us to this, because at Ipsos we deliver the total understanding of societies, markets, and people. And we do that with science as a foundation, because that makes it not only total understanding, but also true understanding. Because you act better when you're sure, and you definitely act better with science as a foundation. And this is not just a slogan. This is actually this holistic approach that we take to use different fields, different disciplines, to bring to our clients a comprehensive, holistic approach that would include neuroscience where it's adding value. And obviously, this is a very special year, 2020. We are going through very difficult times. I think we're adapting pretty well. This is also the reason why we are in my apartment in Brooklyn and not at the office in Midtown Manhattan. But also in these difficult times, we do not compromise that holistic approach. And definitely, we do not compromise the science behind everything we do. but we do prioritize the types of approaches that can meet your needs in these circumstances. So one example of that is our focus on what we call the AAA solutions for these critical times. Those are solutions that are appropriate, agile, and affordable solutions. And I will talk a little later on the case studies about some of them. So you can have an idea of how neuroscience plays a role in this. But these solutions, as you can see here, they go across communication, innovation, tracking, and in some of them, neuroscience is there to add value. Some of them, neuroscience is not needed to provide the necessary insights. But yeah, so some include neurophysiological elements that always triangulated with other different data sources. That could be surveys, qualitative, social media analytics, observation, come together to provide and deliver the true and total understanding. And as I said, we'll see some examples later today. But before that, I want to mention some of the main fundamental things that we are doing at Ipsos referring to neuroscience. So also in order to ensure that we are using the right science as a foundation, Ipsos Sciences experts, we partner with academic researchers. So we have an ongoing partnership with Professors Olivier Houdet and Greg Borst, who are developmental psychologists from l'Abside in La Sorbonne in Paris. And we also have a very close partnership with the lab of our friend Vinod Venkatraman, who's a decision neuroscientist from Temple University here in Philadelphia, Pennsylvania. So we're working with them with three main topics in mind when it comes to neuroscience that are building the foundation of what we need to deliver those holistic and true insights. So these are the three main strategic points. The first one, understanding the flow of experience. That means exploring the cognitive dynamics of decision making. And I will dig into that a little deeper later, because I think this is very important. Going one step beyond the dichotomy of everything is either system one or system two, and be able to approach business problems, research questions from a framework and from a perspective that's more supported by science and supported by data. Then the next thing is learning how to measure all of that. So deepening those insights about these cognitive dynamics with different types of measurement, with multi-channel measurements. And I will explain that also in a second. What combination of neurophysiological measures can increase understanding? What combination of neurophysiological measures with other types of data can increase understanding? So we're doing fundamental research on that in our very own R&D lab. And then we want to put a number of that. We're scientists and we like data. So we want to explain what's the increased variance of the in-market KPI that you want to predict, the level of understanding that you want to meet by adding those neurophysiological measures. So we will explain variance with neuroscience. So in order to explore all of these three areas, as I said, we work with our academic partners to develop this decision-making model that is adaptive and explain real-life research questions, business problems beyond the system one, system two dichotomy. And I'll dig into that in a couple of minutes. Regarding multi-channel measurements, as I said, we have a neuroscience R&D lab that is based in Paris, and with the because like in the past decade, very strong interest in the industry and in society on understanding emotion. Our lab developed a database of emotional images and also videos that have been rated on different emotional dimensions like valence, arousal, and control. Valence is the direction of the emotional response, whether it's positive or negative, pleasant or unpleasant. Arousal is the intensity of that emotional response, so whether it's like exciting or it's more calming. Control refers to how much control you feel you have over that dimension. This is all based on decades of and inspired by decades of academic literature in affective neuroscience. Here are some examples of images that would mean across the dimensions of arousal and valence. This database also includes 20 TV commercials for which we know it market ad effectiveness and memory effectiveness, and also some videos that have also been rated on valence and arousal. So as I said, with our lab, we have collected data on this whole database to try to understand what's the incremental value of combining some of these neurophysiological measures. There's already some results on that, and if you are interested, we have some documentation that we would be happy to share with you. So different signals that we measured and related to neuroscience. One being electroencephalography, or EEG. So that is this swim hat that you can see here on our participant. Each one of those sensors that you see there, it's actually capturing the electrical brain activity that reaches the skull. So your neurons communicate by electrical impulses. When those are synchronized and on the cortex, they're strong enough to reach the skull, and they can be captured from outside. So here we use synthetic channels, medical grade biosemi system with very high sampling rate. And yeah, the magic of these, which is not magic, it's science, but it's that we've been collecting this type of data, this electrical brain activity, for almost 100 years, since 1928. So by this point, we can translate some of this electrical activity into cognitive and emotional processes. And that's kind of frequent right now in the industry, and you might be very familiar with that. We also collecting heart rate information with those electrodes on the left and right wrist, and that's providing also, that's the speed of your heartbeat, and they provide also information of attention and emotional responses. We also collected data on galvanic skin response. So that is the level of perspiration on your skin. When it increases conductance. That can be measured at a very granular level. And that's a signal that's directly related to emotional arousal. And that's also very widely used in the industry. It's also pretty common at Ipsos. It's more challenging, and in fact, right now in the US, not available because of the COVID crisis. We expect that will go back when it's safe to do. We also, in this exercise, recording the face to be able to analyze the facial affective response and combine all of these signals to understand what's best to prescribe to provide insights around emotional response, around attentional response, or even related to predictability of in-market performance. So if you're interested in any of these specifically, please feel free to reach out, and we can talk about it, or I can share some stuff around it. So before we go to the case studies, I want to spend a bit of time, because I think this is really, really interesting, describing for you the Ipsos dynamic decision-making model. One of the things that, over like a year and a half ago, actually at the beginning of the Global Science Organization, one of the things we were struggling with was the having to fit for the industry into the narrative of dual process theory. There are a lot of dual process theories that have been developed in history. They have been very helpful to help understand cognitive dynamics. But after the popularization of the fantastic book of Daniel Kahneman, Thinking Fast and Slow, at some point in the industry and in popular culture, even some intentions of Daniel Kahneman were miscommunicated, and there was a prevailing narrative with two ways of thinking, in which there was the prevailing fast and automatic way of processing and making decisions that was purely emotional, and one that was often wrong, and one that's like slow and purely cognitive. And that's just making a division that is not real, and it was, I reiterate, neither the intention of Daniel Kahneman. So we work with all of our partners on the academic side and across disciplines at Ipsos to develop the Ipsos dynamic decision-making model. And it's based, there are 3 steps that goes beyond the system 1 and system 2. And the first one is actually that cognitive processing is not binary, it's not 2 buckets. It falls along a continuum that ranges from something that's slow and deliberative into something that's more fast and automatic. Emotion plays a role all around. Emotion is not just automatic. Emotion can influence decision making at different levels. And yeah, so it's not 2 buckets, it's a continuum. That's really important. Also, the prevailing narrative is the default interventionist dual process theory that assumes the system 1 is the default, and then sometimes system 2 occur with no clear explanation on what triggers system 2. This sequence is actually not supported by data. What happens in real time, in real life, is that there are multiple processes and threads that are launched, that unfold, that cross-feed, that are abandoned, that are resumed, that are iterate across the course of time from milliseconds into days in some instances. And the third principle that's really important, and it's not actually that new, and it's well located in the well known where it's located in the prefrontal cortex. It's in the ventromedial prefrontal cortex. It's what we call adaptive processing, and this is a regulatory process that monitors and guides all this cascade of cognition, so the person can come to a response or a behavior that's adapted to the context. We call this adaptive processing because this is continuously being adapted by your experience, and also is deeply influenced by different elements, such as the context and the stimulus. Which are your goals and motivations at that point? Very important, which are your past experiences that are stored in your long-term memory, like your associations with the brand, like your associations with the product based on your previous experience with that product. And then the bodily sensations, which is something that relates also a lot on what can be measured with neurophysiological metrics that will definitely influence how we process that situation and will input into how we handle that situation and what's the decision-making process at that moment. So why is this important? And I hope you're as excited about this model as I am. Before I get to that, there's on your console, you have a peer-reviewed paper on this model and also an internally developed scientific report on the dynamic decision-making model, so you can download it and read about any time. But this is important for you because many of these elements, now that are put in a comprehensive way, they can be measured. And if we find the right elements and the right measure for the right research question, we can help you and we can provide good insights for you, for our clients. And I'm going to show, now I'm going to move on to some case studies where you will see how we take this holistic approach by integrating different data sources that fit within the decision-making model. And as you can see, obviously I lead neuroscience, and obviously I think it's very, very valuable, but it's most valuable like triangulated and integrated with the type of data that for each research question would add the highest value. So you can see here that we're not only talking about EEG and reaction times and eye trackings and GSRs, but also about surveys. We're also about observation, also about social, about experiments that would fit different needs and different research questions. So I'm going to move into some case studies. We have specifically 3 in this moment, using 3 of them using different neuroscience physiological measures. They are all they can all be conducted for you anytime in North America, and they are all conducted online. They all fit this prioritization of services that are agile, and they are also, on the fast side. So the first one is about creative evaluation with a new offer of Ipsos in the creative evaluation space, that is Creative Spark. This is a new service that builds on Ipsos' decades of expertise and experience, as you all know from the heritage of ASI Connect, that captures realistic attention metrics in a distracted environment and observes the reality of people making choices. It's also very quick, provides insight in 24 hours, and it fuels the creative process by helping advertisers and agencies quickly evaluate and optimize the creative to power brand growth. It does draw from different science disciplines. I'm going to focus in mine because you're here because you're interested in neuroscience. So something that's integrated here is facial affective response done through the webcam. So we are analyzing the action units of the respondent's face when being exposed to the creative, and providing, again, online measurement of this facial affective response as a diagnostic tool. It can identify this emotional valence, so if the response is positive or negative, and also the level of the respondent's engagement. And what's very important is that this emotional information is provided at such a granular level throughout the creative execution that can provide insights on what scenes are working, what scenes are not working, and when triangulated with the other data sources, it can help explain why it performs better or worse in different KPIs provided by the survey. So I'm going to show an example of a Heineken ad. Let me here. What? Okay, I'm going to show a video of this Heineken ad. So you're going to be able to see the traces for happy, which is positive emotional valence, across the ad. Engagement, that is, there's something happening, there's some reaction happening in the action units, and then negative, that's a combination of different negative discrete emotions. So I'm going to run it. Just a friendly reminder for those that joined the webinar on the phone. The sound is going to come through your computer. So if you have your computer on mute, please turn on the volume so you can hear the video. So I'm going to go ahead and play it. So you could see, I think it's a very interesting example because I think you can see how the ad is building up in the engagement of the participant. If we look at engagement in general, if we look at positive valence, we can identify specific scenes that that are working pretty well in eliciting a positive emotion. So that's there you go. So that's really interesting and really informative as a diagnostic tool. Many of you might be familiar from like the past decade and a half and with the use of electroencephalography as a diagnostic and predictive tool for in-market performance. I did my whole PhD with EEG. That's like my favorite baby, and I've had a lot of experience in the industry with that. And it's fantastic. Something that we've seen, because these times face to face, it's presenting its very own challenges, and we're not able in North America to conduct EEG and eye tracking for credit evaluation these days, is that if we focus on diagnostics, they both EEG and facial affective response are very useful to identify scenes that are eliciting positive emotion. So that's good as a predictive tool. Facial affective response has not been proven that effective, but as I said, and it's our approach, we are integrating different elements that can add value to each other. Predictive is something that ASI Connect, now Ipsos Creative Excellence, has mastered for decades with the CEI metric that has proven predictive for a very long time. Obviously, if you want some more information on that, happy to provide. So the integration of all these different tools is bringing a holistic perspective that's very valuable. I'm going to move on. We have, it's also very easy, device agnostic, very practical, very agile to use reaction time to provide extra insight in some of our offerings. So reaction time is measured at a millisecond level, so with very, very high precision. And different offers across Ipsos. I'm going to present one case following, but I just wanted to mention that it's not the only case, because this is the powerful data that helps us unveil the strength of association in the consumer's memory structure, or also the strength of conviction. So this is now, as I said, integrated across different agile and appropriate offers at Ipsos. So in some instances, like what I'm showing here on the screen, reaction time is used to understand to what extent is an asset intuitively recognized and known as belonging to a brand. And this is very often used by clients on trackers, or also to what extent is an asset unique to a brand and not shared across the category. So this is a very interesting application. I'm going to talk about a different one, and this is when we use reaction time at Ipsos to evaluate innovative elements of innovation. So innovation has become a very agile process these days, and Duel measures the response time in a clever choice tournament design that quickly screen new innovation elements in a way that it's really quick, it's very agile and easy to conduct on the cell phone, and it's also fun for respondents. So this entire experience involves making quick and simple binary choices, right? So you have a first one that is combining different innovation elements that you'd like to test, and in each one of the trials, the participant is like choosing one or the other, and we're collecting not only the preference but also response time. The winners of round one go into round two, the winners of round two go into round three, the winners of round three go into round four. So during that process, we track both the consumer preference, but also the speed of the response to see how intuitive and how easy each choice is. So clocking multiple people through this quick succession provides a clear insight into the winning elements. So in this specific case, we can see that the combination of preference and punch, the preference and the reaction time, divides different innovation elements into 3 tiers. One being the tiers that we recommend to prioritize, then tier 2 that we recommend to rework, and then those that are not performing that well, either both on preference and reaction time, that we recommend to eliminate. So in this very case, we see that reaction time is actually adding a lot of value for all the 4 creative elements that are innovation elements that are on the tier 1. So there's only one that's actually much farther above on preference, but the level of conviction that's provided by the reaction time, it's been a huge differentiator. So it's adding some level of granularity here. And also, as we can see, even for the 2 leading elements, head-to-head competition, we see that Hello Fragrance won a 2-by-1 ratio to eliminate others. So very insightful. And we've been also working, and very excited about this, on webcam-based eye tracking, so where we can track the gaze of the participant through the webcam, so we don't have to bring people in. Before I go into explaining the KPIs and one case that I have for you, I also want to show, because we are very strong, the global science organization that I'm part of, on validations. So we are very strong on 3 levels of validations, one being validity, like is it measuring where it's supposed to measure, reliability, like would it replicate with the same sample later, and added value, is it adding some insights to the research question. So for webcam-based eye tracking, many of you, as we were, might be skeptical of its validity. So we actually, for validity, first evaluated in central location test a number of stimuli, and then using our KPIs to like over 100 areas of interest that we defined, correlated and validated the output, the results of webcam-based eye tracking to a central location. So also happy to share that data if needed. And now I'm going to show first an example of a heat map. In this case, participants had to find the package that's on the bottom right. So you will see a probabilistic heat map that's showing the trajectory probabilistically of the gaze, combining from all the respondents. The focus in the new package not being that much on freshness and the flavor, more on the healthy claim here, naturally sugar-free, that was modified to meet the client goals. So just quickly before we close, we're working on different areas of development. One is like having quick insights from EEG and eye tracking, integrated with qualitative for creative development in one day. We're also working on capturing the galvanic skin response of respondents to better understand content consumption in a natural environment by sending it at home and capturing that data at home. And also we're working on following the decision-making process during binary choices. So instead of just capturing response time in a binary choice, capturing the whole decision tree that provides more information. And if you want to know more, we have some scientific publications. Some of these are in your console. Some of these are in submission right now, and we have been, are being, and will be present on some scientific conferences this year. So two of these SMR and ARF happening very soon. I'll be presenting at ARF virtually, unfortunately, in 2 weeks, on Wednesday 23rd. Also the sensory the Society for Sensory Professionals. I'll be presenting with a colleague next month in October. We also have a number of internally developed scientific reports on some of the topics that I've mentioned, and a number of leadership pieces developed by Ipsos in the past year. So now that we are close to the end, I'm going to close with a video that we have developed that's summing up some of the things that I brought to you today.